Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for 1.2.2. This M&M's is on scaling axes, which is like when you create number lines, there are certain rules for how your number lines need to work. You need to have each one of these units evenly spaced, and you've got to have the counting sequence be consistent. And so in order to do that, like you take a look at this axis here, you know, you go from 0 to 80, and you have to count how many steps does it take to get there. I recommend that you not count the number of tick marks, because a lot of times people will only count those 3, and they'll think they have to take 80 divided by 3. But here's one, here's a second unit, here's a third, and here's a fourth. So you're dividing this 80 into 4 equal parts. So that means that each part has to be 20. So this one would be 20, this would be 40, the next one would be 60, and then the one that's there is 80. Now, if you got the counting sequence wrong and you thought you were supposed to be counting by 15s, then this would be 15, this would be 30, this would be 45. The next one should be 60, right? Not 80. So that's an indication that you got your counting sequence wrong. So count the number 1, 2, 3, 4. It takes you 4 steps to get from 0 to 80. And so you take and you divide the 80 by 4, and that gives you how much for each interval. All right, problem number 70 says, imagine that you have a bag containing 10 marbles of different colors. You have drawn a marble, recorded its color, and replaced it 50 times. So this is an example of experimental probability. And what we have learned is the more times you conduct an experiment, the closer the experimental probability comes to the theoretical probability. So these are the results. Let's go ahead and highlight, and I will, does that look like it's kind of purplish? Yeah, you got 9 purple. How many orange? Let's do a little orange here. You got 16 orange. You've got 6 yellow, and you got 19 green marbles. I'm going to highlight. That would be 19 out of the 50 times you pulled it, you got green. 16 out of the 50 times that you pulled the marble out, you got orange. 9 out of the 50 times you pulled out, you got purple. And 6 out of the 50 times you pulled it out, you got yellow. So if we were to simplify these, kind of round these numbers off, 19 out of 50 is kind of like 20 out of 50, which would be 2/5 or 4/10. So we're going to go with the fact that this ratio is closest to 19 out of 50. So we're going to assume that there are 4 greens in there. Now, is that absolutely certain? No, it's not. But based on 50 trials, 50 times pulling those out, it comes pretty close to 40% of the time you're getting a green. So 40% of 10 would be 4. And now for the orange, 16 out of 50 is pretty close to 15 out of 50, which would be the same as 3/10. And so that would be about 30%. So 30% would be orange, so that would be 3 orange. For the purple, 9 out of 50 is pretty close to 10 out of 50, which would be the same as 1/5 or 2/10. So that's about 20% of the time you got purple. So 20% of 10 would be 2. And then 6 out of 50 is kind of like almost like 12 out of 100, right? Which is pretty close to 10%. And so we're going to say 10% of 10 would be 1. Okay, so just keep in mind, it doesn't make sense to pull out a fraction of a marble or a decimal number of marbles. That's why we needed to round it up to the closest 10% for each one of these, which is how we got those approximate numbers. Okay, and they are just approximations. There's no guarantee that this is correct, but based on this experimental probability, these would be the closest numbers for what's inside the bag. All right, so another probability problem. A fair number cube with the numbers 1, 2, 3, 4, 5, and 6 is rolled. It's kind of like rolling dice, right? What is the probability of getting an even number? Well, how many even numbers are there? 3 out of the 6 are even numbers, so that would be half of the numbers are even, so that would be a 1/2 probability. What's the probability of getting a factor of 6? Well, what are all the factors of 6? They'd be 1, 2, 3, and 6. It's 1 times 6 is 6, and 2 times 3 is 6. So 4 of those numbers are factors of 6, and 4 out of 6 is the same ratio as 2 out of 3. So you'd have a 2/3 probability of rolling a die that is a factor of 6. All right, let's do some proportional reasoning here. Ramona is saving $7.75 per week to buy a new cell phone. The phone she wants costs $125. Obviously, this is not an iPhone, or probably a smartphone for that matter. The phone she wants is $125. For how many weeks will she need to save this money? Okay, well, this is kind of like a unit rate. So what do you multiply times 775 to get you as close as you can get to 125? So first estimate it, and 10 times this is $77, and you take half of that, that's going to probably get you up into the 120 range. So I predicted around 15 weeks. And if we want to solve this problem, we can just take 125 and divide it by $7.75. And I'm absolutely okay with you using your calculator for this. Divided by 7.75, and you get 16, a little bit more than 16.1. So that's where it's about 16.1, 16.12, or 16.13 weeks. But definitely between the 16th and 17th week, that's when you would have enough money. And so now I can go ahead and test that theory. I can say, all right, well, what's 15 times 775? So if you save for 15 weeks, you'd only have $116. If you took $7.75 and you multiplied it times 16 weeks, you're still $1 short, sadly. So even 16 weeks, you're not going to have enough. So really, the proper answer, assuming that you get paid at the end of the week, would be 17 weeks is how long it's going to take before you've got enough money to cover the phone. And let's not even get into the taxes that you're going to have to pay on the phone as well. All right, here's another problem. If 18 inches is equal to 1.5 feet, how many inches is a 36-inch board? How much would be 72 inches, and how much would be 144? So this is where you start getting into proportional reasoning, where you could figure out, okay, well, yeah, 18 inches is 1.5 feet. So what do you multiply times 18 to give you 36 inches so that you can figure out this guy right there? You'd have to multiply it times 2. So we'll multiply 1.5 times 2, and that's how you're going to get 3 feet is 36 inches. We already know that, right? That's a yard. This is a yard. We know how to convert that. And now if it's 72-inch board, wouldn't that just be double? So you double 36, we'll double the 3, and we'll get 6 feet. And then 144 doubles the 172. So if you multiply this times 2, you multiply that times 2, and you would get the 12 feet. Okay. And here we get to practice what we had in our M&Ms, our math notes. So typically what I'll do, let me change colors here so we can see it clearly. We're going to go from 0 to 60, and it's going to take you 1, 2, 3 steps to get there. That means you're counting by 20s. So this would be 20, 40, 60, 80, 100. Here you're going to go 1, 2, 3, 4 steps to go from 0 to 60. So you're going to go up, you're going to increase by 60 in 4 steps, and 60 divided by 4 is 15. So that means this is 15, 30, 45, 60, and 75. Here you're going to take 1, 2, 3, 4 steps to get 100. So 100 divided by 4 is 25. So we're going 25, 50, 75, 100, 125. And this last one, it only takes 2 steps to get to 100. So we're going to take 100 divided by 2, and that means we're counting by 50s. 50, 100, 150, 200, 250. All right, So good job on your homework. Hopefully you understood all that fairly well. Go ahead, head on to your, I guess, what are we doing next? I guess we're going to go and do our next lesson. So good luck with that. Make sure you're recording everything in your journal, in your math notes, whatever you're choosing to use for your math. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, walk